Hey YouTube, my name is Roland and today I'm going to show you guys the Bugout and survival power system that I've come up with. I chose this because of the easily renewable and concealable power source that this solar panel battery combo is. This is the 27 watt Instapark foldable solar panel. It's 12 inches in depth and 36 inches in length. So let me get this off of there. It has 4 separate panels that are actually pretty flexible. You can bend these pretty good. You won't be able to fold them on themselves or anything like that, but if they get banged around, it's not a big deal. So again, this is a 27 watt. Right here, I'll show you some of the specs on it. This is the Mercury 27 watt solar panel by Instapark. It has 2 USB ports that are 5 volts, 3 amps, which is about 15 watts. It has a 12 volt plug as well that does, it actually ends up being about 15 to 18 volts. I measure it later and it's about 19 volts. It does 27 watts max. So this is again, it has 4 panels that are flexible, and it's got these nice tie downs on the corners of everything so that you can tie it to your pack or something like that if you needed to keep it in sunlight and walk around. Let me fold this up for you guys, and on the back of this here, by the way, when it's folded up, it's 12 inches long and about 8 inches wide. It's got this pocket on the back where it's got its two USB ports right there, and it also has a 12 volt cable. This cable can plug into small laptops and things like that and give them power to charge themselves with. The cable is quite generous. I think it's about 6 feet long, so it's plenty of room to have the panel on the outside of your pack and then have this all the way inside charging something inside of your pack. It just so happens to fit this Anker battery in here really easily. It just fits just great, even being on the side of the USB here. Let me get out my scale and show you guys the total weight of this package. Okay, so I've got my scale out here. Let's set this on here and see how much it weighs. Weighs 2 pounds, 5 ounces. And if we throw the battery on there, which I usually keep together, it's 3 pounds, 6 ounces. So pretty lightweight system with the high wattage that this is for a portable system. Let me go over the features of this battery here. This is the Anker battery that I choose to use with it. It's a 20,000 milliamp hour battery pack. It has lithium ion batteries in it. Let me get you a little zoom in here so you guys can see that. I'm sorry, lithium polymer batteries. I've actually opened this up and it has 4 batteries in here, so each one of those ends up being about 3 volts or so, so that works pretty well together to provide the voltage that it can. This, let me get you guys a close-up on this back here. It takes 12 volt in, 2 amps, and it can output 9 volts at 2 amps or 12 volts at 1.5 amps out of this smaller plug right here. It comes with a little adapter so that you can plug it into the same 5.5 by 2.1 millimeter plug. Then it can do its USB with a total of 4.5 amps, which is a lot of power to USB devices, way more than an iPhone or anything else will typically consume. Again, this is a total of 20,000 milliamp hours, and for reference, an iPhone has a 1400 milliamp hour battery, so it's quite a discrepancy between this and common devices. I mean, this is basically just all battery. It's enormous for just being a battery. So a lot of people are asking, probably thinking, you know, why do you need this much power for a Bugout bag or something like that? Well, I wanted to be able to charge a couple of devices that my wife and I use when we go camping or things like that. And so I carry this solar panel and this battery, which is for both of us because I don't want her to have to carry that extra weight. So let me pull out the things that we bring with us. We bring 2 of these Wouxun or Woxon or whatever batteries, ham radios. It has this is one of the batteries it comes with. This is a 1300 milliamp hour battery, and it just snaps on the back here, and I can recharge it using this little dock for this. So this slides into here. Sorry, that made some noise. Slides into here and charges. This originally came with an AC input and a DC 12 volt input. So I swapped this plug to work with this guy so that it slides right in and is actually the correct size to charge this. So this solar panel can directly charge my ham radio without having to go in between from this to the battery and then to this battery, which is just a waste of energy. But this can do this directly, and if for some reason I'm unable to get this docked properly or something, I can just charge this quickly and in my pack and then charge this later at night or something like that. But most likely I'm going to be charging something like a headlamp. So this is the headlamp that we use, and I'll put a review and talk about some of these later. I ran into some problems with Nightcore, but so far their headlamps seem to be good. These have an 18650 lithium ion battery in here, and they're pretty exceptionally bright. Oh, sorry. It recommends to keep it twisted a little bit to keep the battery from draining. So it's a very bright flashlight. I believe it's about 900 lumens. So let me twist this back a little bit. So this one charges by micro USB right there. So this can plug directly into the solar panel here and charge on its USB port, or it can charge on one of these USB ports here. And again, these are the intelligent USB ports, so if the headlamp the power that it's drawing drops down significantly, this is going to notice and it's going to think, okay, it's done charging, and it will disconnect from this and not provide any power to it. So that saves this battery from being wasting energy charging a device that's already fully charged. So with two of these radios that are 1300 milliamp hours, and then with two of these 18650 batteries, which are lithium ion batteries. These are 3400 milliamp hour 18650 batteries. Then that adds up pretty quick, and I wanted to make sure I had some spare room to recharge these. So if both headlamps and both radios were completely discharged, and then I also have some hand lamps as well that take 18650 batteries. So with hopefully this guy will be able to recharge all of those devices from the solar panel. And again, the solar panel or this battery can charge all of these. So for anybody who doesn't know, I've been talking about this 12 volt connector the whole time. One of the reasons I like this 12 volt connector is because, one, it plugs right into here, and then two, 12 volt is actually what a car uses. So a car battery or a car cigarette lighter outputs 12 volts. So this can be charged just directly by plugging into a car. So if I'm driving down the road, I can just plug this in and recharge it. Or I can plug in my dock for my ham radio and recharge it. So this also can be charged off of a car, this solar panel, or this battery. I also, let me grab it over here. I swapped the power connector for this battery charger. This is actually for the camera that I'm using to record this video. I bought this on Amazon so that I could recharge these batteries from this solar panel or this battery or a car. Because the original one it came with only had this little wall plug, which is good for at home, but if I'm outside recording some videos, I need to be able to recharge the batteries. So this, I swapped the connector to be this same connector that this guy comes with, so I can recharge my camera to continue recording just directly off of this solar panel, or again from this battery or from a car. So that's why I like this 12 volt. This guy just so happens to do the 9 volt as well, and I don't really use that one right now, but let me turn this on for you guys and I'll show you toggling between the 12 volt and the 9 volt. So this comes on and it doesn't really show up on camera, but if I press and hold this, and then it's going to start, it'll turn on 12 volt, and I can toggle between 9 volt and 12 volt. So right now the 12 volt turned on, and I'll show that to you in just a second. And then so I can switch between 9 volt and 12 volt. So I'll just press and hold this until 12 volt starts blinking, then I tap and it switches over to 9 volt. So now this port up here is outputting 9 volts, which can charge other devices that I currently don't have, but it's just a nice feature in case I run into something that needs 9 volts. I can charge it using this 9 volt as well. So that's a really nice combination that this guy can do. So with this guy, I could convert this panel 12 volt in here, and then I could have 9 volt coming out. So it did say in the manual for this that if you want to charge and discharge it at the same time, it can do that, but they recommend that you charge it or discharge it because it will run the battery down faster. So I've made sure to do that, just charge this guy up. So you notice it just turned itself off because nothing was charging on it, and so it's like, I'm done, turned itself off, not wasting any more energy on that. Great feature. I find that I can charge this guy up to 100%, and in a month or so it'll drop down to about 80% that it is right now, because I think with lithium-ion batteries they just tend to switch down to there, and that's totally normal, and it just sits there for months in addition to that. So it will hang around 80% or so. So, you know, just charge it up before you go on a trip, or charge it up when you're hiking around, and then you're going to have 100% use that milliamp hour difference between that, 20% difference there to recharge your devices. One important feature of this battery is that it has this little 12 or 9 volt output. So it comes with this cable here that you can use to charge other devices with. So it's pretty smart. It noticed that I plugged that in and turned itself on. So let me pull this out, and this is the same connector that the solar panel outputs with its little 12 volt connector right here. It's the same size plug, and so that's why I was really excited by these two things that just so happen to use the exact same plug size for charging and discharging. This can also, of course, connect to the ham radio charger here, and this can charge up a ham radio. Let me show you that. So this guy turned off. I'm just going to make sure to turn it back on. It's doing 9 volt. Let me unplug that. I don't want it to actually do 9 volt. There we go, 12 volt. Bam, there we go. So now I can recharge my ham radio off of this battery or this solar panel. So funny story behind this guy. I might tell you guys a story about why I had to put this carabiner on here, but it's definitely worth keeping that carabiner on here. Alright, so I'm going to be taking this outside, and we're really going to see, does this provide the 27 watts or about 2 amps that it says it can. To run these tests, I'm going to be using my multimeter to detect how much power the solar panel is providing to the electronics it's charging. So for anybody who's not familiar with these, it measures different fundamental aspects of electricity so that I can understand how much electricity is necessary to charge specific devices. So I have this little connector right here that allows me to connect the solar panel to a device and to get in between the device and what's being charged. So it's got its negative green cable going through it here, and the positive is red. I just clipped it off. So I can clip this onto here and measure the voltage, or I'm sorry, to measure the amps that are flowing through the circuit. So for anybody who doesn't know basic electronics, with a when you're measuring voltage, you must you go across the wires. So I would measure like from the inside to the outside of here. I can measure the voltage through there. But if I want to know how much electricity is flowing through here, which is called amps, you need to be in the way of the circuit. So I can put this in the way of the positive, so the positive electricity will have to deviate through this and then back over to this side and back into the device that it's charging. So that way I can monitor how many amps this is pulling. Alright, so I'm outside with my solar panel unfolded. All 4 panels are pretty well facing the sun. There's no clouds anywhere near the sun, so we're getting nice full sunlight. This solar panel comes with a 12 volt 5.5 by 2.1 millimeter barrel plug, and I'm going to be testing the amperage that this battery consumes using the solar panel to see if this solar panel can indeed charge this as it claims. This requires 12 volt 2 amps input to be charged. This claims that it has 12 volt 27 watts. If you do the math, this should be enough power to charge this guy, just about enough to charge this guy. And so I've built this little connector here which will allow us to hook my multimeter up to this and see what's actually going through this circuit and see that it is indeed being charged correctly. So I'm going to go ahead and we'll check the voltage for this first. Okay, so I've got my positive clipped on here, and the outside of this barrel connector should be negative, so I should be able to see the circuit completing through this multimeter here. And we get 17.6 volts. Let me rotate this for you so you guys can see. 17.59 volts. So it says it's a 12 volt charger, 12 volt solar panel, but it actually, if you see the little writing here, it says 15.7 to 18 volts. So that's pretty important, but I believe I've used this plenty enough and I've seen this charge this no problem. So I'm going to go ahead and connect this over here, and you guys will be able to see that this charges properly. Alright, I've reattached the clip onto here so that I don't get any disconnects and stuff after I've connected this. I've switched my multimeter to use the 10 amp circuit and switched it over to amps. Let's connect this and see what kind of amps we get while this is charging. Alright, this shows that it's got the little indicator showing that it is being charged, and this is pulling about 1 amp to charge. This is at 82%, so it's still got plenty to go. I find that when I leave this for a long time, it ends up being about 80%, which makes sense with what a battery is going to do in some long-term storage like that. So this solar panel is able to produce 1 amp for this battery. I'm surprised it's not putting out a little bit more than that. Let's see if we can angle this a little bit better. Let's see. Yeah, that is providing a little bit more amperage, facing directly towards the sun like that. Alright, we're at about 1.2 amps. So I'm going to try cleaning off this panel a little bit with just a little bit of water and see if that will increase the amperage for this battery. Alright, so I've got just a paper towel with some water, and I'm just going to wipe this down, and we're going to see if we can get the amperage to increase. That came disconnected, but I'm going to leave that for now. Okay, so I've got this cleaned off, and let's reconnect this amp meter here and see what kind of amperage we get. I'm betting there's not going to be a huge difference. It's about 0.9 amps as it was before. Let's angle this towards the sun, see if we can increase that a little bit. Only about 1.2 amps. So cleaning it didn't really increase the performance as expected. I'm going to take this inside and charge this battery off of a wall socket adapter that should be able to provide the amperage that it needs. So we'll see if this consumes more. It could be that this is simply consuming all it needs, or it could be that the panel cannot provide the amperage that this is able to take when it's charging. So let's go inside and check that out. Alright, I've come inside and I've got this extension cord here with some power going to it. I have a 12 volt 2 amp adapter here that happens to fit the battery perfectly, which is awesome. This guy is a little finicky, but works. So I'm going to plug this in. And show that it does charge it just great. It leaves this light on the whole time. Let me see if I can get the camera to show that. Come on, camera. I have to get really close. 83%. So, and it is charging. You can see the little icon, the little dot up there. Sorry, it doesn't show well on camera. Okay, so let's hook this circuit up and let's see what kind of amperage we're getting across this guy. Got a little stand there. Okay, I've got this guy connected, and it's showing that it's charging. The light's on, which I guess should be proof enough that it's charging, and this is showing 1.8 amps. So it looks like that solar panel with full sun like that cannot provide as much as this is able to consume. So I might talk to the manufacturer of that panel and see if there's something I'm doing wrong. I don't think that it is this little device I soldered together here. I don't think this is causing a problem because it's able to provide enough power for this, but the solar panel isn't producing enough amperage to charge this at the 1.8 amps that it apparently consumes. So this is good to know because I can take it into account of how long I need to charge this battery or any devices that use that 12 volt connector. So I'm pretty disappointed with that panel not being able to provide the amperage that I thought it could. One thought I have though is that it could be that with the panel outputting 17 or 18 volts like it is, that it doesn't need to put out as many amps to charge this battery. So it getting to about 1.2 amps is probably close enough to exactly 12 volts. Well, actually, no, let's double check that. 12 volts with 1.8 amps that this adapter provides. Let's double check the the voltage that this adapter is outputting. There we go. Okay, so with this connected up, it's getting 12.2 volts. So I think if I do the math and stuff, that's probably about what is expected with this guy claiming that it needs, let me show that to you, 12 volt 2 amps input. Alright, so I've done a little bit of simple math here with the volts, amps, and watts to see what might be going on behind this charging. So the solar panel was outputting about 18 volts and about 1.2 amps, which comes out to 21.6 watts. This adapter inside is putting out 12 volts, 1.9 amps, and it's about 22.8 watts, which is pretty close in wattage. So this guy must be changing it to what it needs and still consuming the same amount of power. Power being the amount of wattage that it's consuming. So I think that that panel is actually outputting about what it should be. I'm sure in a perfect world with a better angle and perfect sunlight or something like that, I might get some better performance out of it. But now seeing this math, I'm actually pretty happy with that panel, and especially happy with this battery by Anker, that it seems to take even an imprecise voltage and it deals with it and charges itself with it, which makes me very happy.